Welcome back to another episode of Mr. Harper Smith's Math Class. Today we're talking about integration some more. Anti-differentiation is another word for it. Before we start today though, we needed to go over some basics with exponents, okay? We're not gonna be dealing with whole numbers as exponents today. For instance, let's say we have the square root of x. What does square root mean as an exponent? Because square root is really just a symbol for a special exponent. Okay. Well, it's a square root. Sometimes squares we incorporate the number 2. So what does it mean? It really means x to the 1/2 power. All right. Whatever your basis for your square root, cubed root, fourth root, those are just 1/3, 1/4, 1/5. Okay, that's all that the square, cubed, or fourth means. It means it's an exponent as 1/2. So if we wrote this would be x to the 1/2 power. These are the same thing. In calculus, we can't really take the derivative of a square root, but we can take the derivative of x to the 1/2 power. Okay? Over here, if I have the 5th root of x cubed, what power is that? What power is the 5th root? Well, it'd be over 5, but we had 3. So this is really x to the 3/5 power, okay? This is just a different way of writing it. That's all that it is. So let's take another look at some calculus problems now. Well, let's give this little problem a try then real quick. So we've got the square root of x, we want to take the derivative. Well, before I can really do this, I really need to make this an exponent, because we only know how to do it if it's x to some power. In this case, the 1/2 power. So how do I integrate x to the 1/2 dx? Well, remember, Harper Smith always starts out by adding 1 to the exponent. Always add 1 first. Add 1 to exponent. That is always my first step. So in this case, if I add 1 to 1/2, that is 3/2. We almost always will write our exponents as a fraction, an improper fraction if necessary. We don't ever separate it and say 2 and 1/2 because it doesn't help us too much. If you think about it, here we want to know that it is a square root. 3/2, well, that is the square root of x to the 3rd or whatever, okay? That's why we leave it as improper, because this is telling us the exponent, this is telling us the root, square root, cubed root, whatever. Well, 3/2 times what is 1? It'd be 2/3 plus c. Okay. If you didn't know how to do that, you could say 3/2 times something equals 1. How do you get rid of the 2/3? Multiply by 2/3 times 2/3 to x is 2/3. Okay? That's your initial equation. All right, let's try this problem. We have x to the 5th power, and we're taking the cubed root of it. We want to know what does it integrate into. Well, the first thing I need to do is I need to get rid of that square root, the cubed root, okay? We can't have the radical there. We have to write this as purely an exponent. So we want to integrate x to the 5/3 power dx. So that gives me y equals, add 1, that's going to give me x to the 8/3 power plus c. 8/3 times what is 1? 3/8. Here's another exponent rule that you need to know. If you just have x in the bottom, there's a couple of you that did the extra credit module last term that know how to do this. The rest of you probably don't know how to do it. How do you take the derivative if x is in the denominator instead of in the numerator? Well, we have to get this all to be on top. We need this to be x to some power. Okay, well, what power is it? It's x to the -2. If you ever need to bring something from the denominator into the numerator, you just make its exponent negative. Okay, just a little reminder, dx. Now I integrate y equals x, I add 1, that gives me -1 plus c. -1 times what is 1? -1. Bam! Now we got a really tricky one. So we have not only a fraction, but we also have a square root going on. What do we do? Well, let's see. We've got, let's see here. Let's turn this into a nice exponent instead of the square root. So that's going to give me an integration of 1 over x to the 1/2 power dx. I can't have the x in the denominator though. Do you remember how to get the x into the numerator? If you said you have to make the exponent negative, you're correct. So we want to integrate x to the negative 1/2 power dx. Well, add 1, that's going to give you x to the 1/2 dx, sorry, not dx, plus c. One half times what is 1? 2. 2 times 1/2 is 1. There you go. So, I mean, heck, you could even rewrite this as y equals 2 times the square root of x plus c. Interesting. And 1 over square root integrates to become a square root. What? That's crazy, dude. Here we go. Let's try this one now. This is going to be the last one that I do. Then I'm going to let you guys try a couple. Unless you're already feeling comfortable with it. You're like, oh, Harper Smith, this is easy. Then cool, do your own thing. Forget about me. As for now, though, let's give this one a try. So we have, let's see here. We want to start off with this bottom, maybe make that an exponent instead of a cubed root. That's going to give us 3 over 10 x to the 7/3. I want to get the 7/3 up top. So I want to multiply 3 over 10 x to the negative 7/3 dx. Well, we can integrate now. So let's see here, this is going to become, I need to add 1. So if I add 1, that's going to become 4 over 3, x to the 4 over 3, it will be negative still, plus c. All right, well, let's see here, 4/3 times what equals 3/10? 4/3 times what equals 3/10? Remember, that's a trick you can always do. Multiply by 3 over negative 4, multiply by 3 over negative 4. That's going to give you x is negative 9/40. Ooh. That was your initial equation. Okay. All right, next one's your turn. All right, I want you to try both of these. Pause the video, restart the video once you have the answers. Okay, you should have paused the video. You should have the answers by now. Let's give them a try. You ready? So, with this one, we first need to turn this this radical into being an exponent. All right? So, we've got 5 over 4. We've got x to the 1/4 power dx. I can't have x in the denominator. I need to bring it up to the top. How do I bring it up to the top? Make the exponent negative 5/4 x to the negative 1/4 power. Notice I didn't flip the exponent. I just made it negative. dx. I think now I'm ready to integrate. So I've got y equals, I need to add 1. Remember, that's always the first step. Add 1 to the exponent. And that's going to give me x to the 3/4 power plus c. 3/4 times what is 5/4? Now let's look at this. 3/4 x equals 5 over 4. Multiply both sides by 4/3. Times 4 over 3. 4's cancel out. It gives you 5/3. 5/3, when you multiply it down, bloop, gives you 5/4. Perfect. That is your answer. Let's try this one over here now. Okay. So here we have 4 times the cubed root of x over 3. Well, we don't have to make that exponent negative. That's nice. But we do need to make this cubed root of 3 a fractional exponent. That's going to give me 4/3 x to the 1/3 power dx. I'm now ready to solve. The first step is always to add 1 to your exponent. So that's going to give me x to the, 4/3 dx. Sorry, not dx, plus c. 4/3 times what is 4/3? This is an easy one. It's 1, so we don't have to put anything there. So the answer is y equals x to the 4/3 power plus c. All right, if you have any questions, shoot me a message if you're not currently on the Zoom class. If you are in Zoom right now and you still have questions, please let me know. I'll start a separate breakout room. I can help you. I really want to see you succeed. If you feel good about it though, jump on to the homework and give it a try. All right, see you guys.